Hey, welcome to Area and Perimeter, our first video for the course 1520. This is going to be an epic one. I apologize in advance, but make sure you consider maybe you should just check out the slides first, and if you can do the work, you can check your answer, and then you can find where to go in the video if you need to. If you're completely lost, by all means, tag along, and hopefully we'll come in at under 40 minutes. So speaking about area, we've all learned this before, but often it's been a really long time since we focused on it. When we talk about area, we talk about two dimensions. So you're thinking about things like the surface of your table or tiles on a floor or a piece of paper, something that has that two dimensions. You wouldn't be able to pour stuff into it, but it's not just a line or a string. When we're measuring area, our units are always squared, and it doesn't matter what you're using, inches, feet, meters, they'll be meters squared, inches squared, feet squared. Your input measurements must be the same. So I can't do centimeters times millimeters. I have to change one of those two to match. So make sure that you're using centimeters times centimeters. That makes centimeters squared. When you're doing area calculations, we're done with fractions. So if you have something like 3.5 feet, you're going to change that to 3.5 feet before you continue. Only use decimal units and you don't convert back. You stay in decimal units once you work with area, which is kind of nice. I always recommend that before you do the math, you do any conversions you need to. So if I ask you for an answer in feet squared, don't do it in find square inches and then change that to square feet. It's just a little more complicated than converting linear measurements, and invariably people forget what they're supposed to do. So prepare your stuff before you math it. If I want feet squared, make all your measurement feet, then do the area calculation, and you will get feet squared. And we have formulas that will be provided in Brightspace for your geometry calculations, and area really just depends on what type of shape you're trying to find the area of. Speaking quickly about perimeter. So area is a two-dimensional measurement. Perimeter is one-dimensional. It's a line, and it's a line around the outside edge of any object. So when I look at, let's say over here, if I was going to combine those objects, my perimeter would be all of the outside edges. So it would be, around the square. Sorry, not a very good drawer. All these lines would make up my perimeter. Another way to think of it is the sum of all the outsides. You can use any unit of length once again, but please add the same things, like don't add centimeters to feet or centimeters to millimeters. Make sure they're all in the same unit, whatever it may be, before you add them together. The first type of shape we're going to talk about are quadrilaterals, and those are figures that have four sides. So we've got a few main groups of this. We've got parallelograms, and to be a parallelogram, you need to have two sides that are two sets rather of parallel sides. So top and bottom are parallel, and the two sides are parallel. When you do that, that means the top and bottom will be the same length, and the two sides will be the same length by definition. If you take that parallelogram and make all the interior angles 90 degrees, or a square, you've created a rectangle. And once again, they'll still be parallel, right? Top will be parallel to top, and bottom will be, to bottom, and the two sides will be parallel. But now you've got a shape that's more regular, something we're used to. And we can take it and make a square. So a square is just a rectangle where all the sides are the same length. And our last shape, which is the weird one, it's called a trapezoid. The top and bottom are still parallel, but nothing is the same length, and the two sides don't have to be parallel to each other. In fact, they're not, in order to be a trapezoid. Here are the formulas, and I've kind of cut this off the formula sheet so you can see what you would be expecting. So if you have a rectangle, we talk in terms of W for width, L for length, And then if we wanted to find the perimeter, the symbol is P for perimeter, and you just add all your sides together, or you can add the length and the width and multiply by 2, or you can also add 2 times the length plus 2 times the width. Oops, those all work. If you want the area of a rectangle, long side times short side, length times width. Our parallelogram, perimeter is just adding up all the sides, and it kind of follows the same rule. You can do 2 times b times c, b plus c rather, or you can do 2b plus 2c. And the area is still the base, but instead of doing it times this slant, you want to make sure that you're using the height for your multiplication. The trapezoid has been given all these various different letters to describe things. So once again, the perimeter is just the sum of all sides, and I'm not going to have any shortcuts here because they could all be different. A plus B plus C plus D will give me the perimeter. For the area, you are going to take the 2 parallel sides, so A and B, and you're going to add them first. Then you're going to multiply them by the height, H, and then you're going to divide by 2. You don't pay any attention to C and D when you're calculating the area. And a square isn't on here because it's not really necessary, so if you wanted to do a square, I guess the shortcut is you could call one side S, and because they're all the same, the area is S times S, which is the same as S squared. And the perimeter, just because all the sides are the same, you could say that the perimeter is 4S, but you can just do it the long way too. Alright, so let's do some examples. Find the perimeter and the area of the figure below. So I'm going to write down my formulas. And perimeter equals 2L plus 2W. You can use any version you want. Okay, and I'm going to call this one the length, and this one the width. And it doesn't really matter which one I call length and width for this. So if I want to find area, 23 times 13, and I'm totally dropping x as multiplication because it's now an algebra symbol. And once you do that math, you're going to get 299. Your unit, what went in? Centimeters, but now it's squared. Your perimeter, 2 times the length, which is 23, added to 2 times the width, which is 13. So respect your order of operations. Do the multiplication before you do the addition. So that's going to be 26. Sorry, that is not going to be 26. That is going to be 46. It's a long day here. And this one's going to be 26. And those hopefully will add together to give you 72. And because this is just a linear measurement, it stays in centimeters. So that's our simplest example, one plain old shape. Sometimes we have shapes that are not squares. We call these composite figures, but they're usually made up of things we know. So when I look at this, I'm like, okay, well, this is like 2 rectangles that have been stuck together. I could like split them right here if I wanted to. You could split them other places, but that's where I'm going to do it. I'm going to call this rectangle X, let's say, and let's call this one rectangle Y. And I know that if I want to get the total area, if I find the area of X and I add it to the area of Y, that will give me all the shaded yellow part. So that's not too bad. So let's start with X. And I've got a length and a width for X, 24 times 10, 240 inches squared. Now I'm going to look at Y. So Y has, well, I'll call this one the length, but I'm having a little harder time figuring out what the width is. But if you are missing a dimension, just look at all the other dimensions that go that way. So if I look along the bottom here, I've got 17. And if I look all the way up to the top, there's 10 inches. So what's left over? This is my W for my rectangle Y. So 17 minus 10, 7. So to find Y, 10 times 7, and the area of little rectangle Y is going to be 70 inches squared. My total area, add those two together, 240 plus 70 equals 310 inches squared. Okay, now let's talk about the perimeter. We know we added this piece in, and we're also missing this piece. But once again, if I look over here, I've got 24 inches long. And if I look all the way to the other side here, I used up 10. So 24 minus 10, 14 left over. So this side is 14. So just filling in those things. And I guess I'll call these, and I'll get a different color because it's getting messy. All my different sides. If I start here, this could be A, B, C, D, E, and F. So just making sure you're going into that math with enough sides. I need to go A plus B plus C plus D plus E plus F. And notice you're not including anything from this interior part. That is not part of the perimeter. It is not on the outside edge. Alright, here we go. 14 plus 7 plus 10 plus 17 plus 24 plus 10. And our total perimeter, 82 plain old inches. Here's another composite figure. It's got a couple of things going on. It's a little overwhelming at first, but it's not too hard when you take a minute. So I'm going to call this big thing shape X. And I've got a hole, shape Y, cut in this thing. So if I want the area of the blue shaded part, I'm going to basically take the area of the big X figure, and if I subtract what I cut out, that hole, that'll leave the blue behind. Okay, so what is shape X? Shape X is a trapezoid. So to find the area of X, I'm going to kind of redraw it here. I need these kind of figures here, and I'm actually going to need the height of it too. And the second thing I see that's a problem is that I have feet and inches. So I need to change everything to decimal feet, and I'm choosing decimal feet and not inches because the question asked me for the answer in square feet. So right away, 2 divided by 12 to change the feet to inches, and of course I'm rounding a bit. 11 divided by 12 to change the inches back to feet. I think I said it wrong before. 9 divided by 12, 0.75, just smash it together with that 3. And 2 divided by 12 is still that 1.17. And 1 foot can stay as is. Okay, so looking at figure 8, the measurements I need are the top and the bottom, and the height, which is 2.92. The formula for a trapezoid, if you look on your formula sheet, it is A plus B times the height divided by 2. Okay, so 3.17 plus 3.75 times 2.92 divided by 2. Order of operations. Do the addition within the brackets first. And then it's kind of willy-nilly. You can do any of the rest of the math, and you're going to get about 10.10 feet squared. Y, I'm going to do it up here, sorry, is a shape like this. Whoa! Very terrible. Y is a parallelogram. So all I need is base times height. So formula is base times height. I see that the base is 1.17 And the height is 1, so that's nice. Y is 1.17 feet squared. To find the total area, x minus y, so it's 10.10 minus 1.17, and my answer is going to be 8.93 feet squared because we are in area. So I'll just give that a little bit of a highlight so we can see where we got the answer. And back to black. And here we go. Find the perimeter of the shape below. So not area, because if this was area, I'd be like, oh, it's a trapezoid, and that would be pretty straightforward. I'd be 5 plus 8, multiply that 3 by 3.2, and then divide it by 2, and get the area. But I want the perimeter, so I have this kind of dimension over where the question mark is. That's a mystery. So think about what shapes you have here. This is like a rectangle and a triangle. And we haven't really talked about finding the area of a triangle, but I don't need to, because I think you guys have already learned Pythagorean theorem, where c squared equals a squared plus b squared. And that just says for any right triangle, sorry, so bad, the long side is always c, the hypotenuse, and you can always find it by squaring the two shorter sides. So I know this is 3.2 because it's going to translate all the way across. I need this little piece, but once again, the whole distance is 8. Part of it's used up by 5. 8 minus 5, 3 centimeters. So c squared equals 3 squared plus 3.2 squared. And c squared is going to equal, do the squares first, once again exponents before addition, order of operation, 19.24. And to undo a square to find the length, this is not the answer, 19.24, you're going to take the root, square root, calculator button, and you'll get 4.39. It should always be bigger, it shouldn't be insane. Alright, so now we have 4.39. And remembering that the perimeter is just the sum of all sides. So we've got side A, side B, side C, and side D. And we found this 3 down here, but that's part of the 8, so we don't have to consider that separately. And we don't use any inside measurements, only the outside. Five plus 3.2 plus 8 plus 4.39. 20.59 centimeters, which is right. If you wrote 20.6 centimeters, that's also right. All good. The next thing we're going to talk about are our triangles. We have a lot of different types of triangles. A scalene triangle is just a messy triangle where nothing's good. All the angles are different, all the sides are different lengths. If you are a right triangle, that's when we can use that Pythagorean theorem. And in order to be a right triangle, you have to have one square angle. If you are an equilateral triangle, all of your sides are of equal length. And if they're all the same length, that means all of your angles are the same and they're all 60. An isosceles triangle has 2 sides that are the same length, but the third side doesn't have to be. Triangle formulas. So we have side A, B, C, and we have a height. And a height is measured perpendicular. It's from the base is established to be side B, base. And then you always measure your height from the third corner perpendicular to your base. So you get that square angle right there. And that is a measuring use. Perimeter is just the sum of all the outsides, but for area you need that height. And once again it's going to be base times height, but this time we are going to divide that number by 2 to get a final answer. And be careful because sometimes the height can be confusing. Like if you have a right triangle and you decide the base is here, the height happens to be one of the sides. And if you have a crazy triangle, I'm trying to draw this so it actually looks like a triangle. Sometimes the height can't be found within the triangle and actually is drawn outside the triangle. These are all valid. Let's do some examples with triangles and their friends. So we're looking for area and perimeter below in square inches. So I'm going to make sure that I change all of my measurements to inches. 10 inches, that's good. 1 foot 7 inches, so that's 12 inches plus 7 inches, 19 inches for this side. Okay, so let's start with area. Our base is going to be 19, and our height is given to us as 10. Area of a triangle, base times height. Don't forget to divide it by 2. 10 times 19 over 2, and that should give us 95 inches squared. Okay, I want the perimeter. I've got 2 sides, but I'm missing the third. This is a hypotenuse. It's across from the right angle, so if I was going to do Pythagorean theorem, that would be the C side. So I can use that c squared equals a squared plus b squared to find it. Doesn't matter which one's a or b, but it does matter which one's c. And we get c squared equals 461. Now remember, to find c, you must take the root, and it's going to be about 21.5 plain old inches. Okay. Your perimeter is the sum of all sides, so you're going to take 10 plus 19 plus 21.5 equals 50.5 inches. And I've noticed a thing here. The perimeter is not going to be in square inches. It will be in plain old inches. Another compound shape. So just looking careful, what you see, there's more than one shape. Divide it into things that make sense, not weird stuff. Makes the most sense to have a triangle X and a rectangle Y. And to find the combined area, we would find the area of the triangle and we would add it to the area of the rectangle. Alright, so let's look more closely at that triangle. We see that, oh my land, sorry. We see that it is 13 yards across the base, and it has this beautiful height of 6 yards. So we're going to take our triangle formula, base times height divided by 2. 13 is our base, 6 is our height. We divide it by 2, and you should get 39 yards squared. Our rectangle, very, very straightforward, a length and a width. So the area of a rectangle is length times width, and that's just going to be 13 times 4 equals 52 yards squared. And then to find the total area, add them together. 39 from the triangle, 52 from the rectangle, equals 91 yards square. One last question. Area and perimeter, everything's in inches, so I'm going to give you answers in inches and square inches. I've got a rectangle with a hat that looks like a triangle, and I'm going to call the triangle the X shape, and the rectangle, which looks like it might be a square, the Y shape. That's fine. So our area is going to be addition, the total area of this composite figure. I am going to look more closely at the triangle, see what I can see about it. Okay, So they didn't give me triangle dimensions, but they gave me enough information looking at that 16-inch side. I see that 10 of it is used up here, and then 16 minus 10 will give me the height of my triangle. Likewise, looking at the base of the triangle, I have 10 across the bottom. What measurements are parallel? I'm using 6 up along here. 10 minus 6, 4, which corresponds to the base of the triangle. So for our shape X, we are going to do base times height divided by 2, which will give you 12 inches squared. And then let's look at our rectangle. And it does happen to be a square, so you can either do 10 times 10, length times width, or you can do 10 squared. They will give you the same thing, 100 square inches. And then if you want your total area, 12 plus 100. Now I've used up a lot of area. I still have to do the perimeter, but I'm going to go back. I'm going to switch perimeter to blue. And in order to find the perimeter, I've got everything I need. I've got side A, B, C, D. I need the full, not this, but I just need E, which is like the hypotenuse of a right triangle. So once again, C squared equals A squared plus B squared. C squared equals 6 squared plus 4 squared. 36 plus 16. And C squared equals 52. And C equals the root of 52. Same math every time. C equals 7.2. So we're going to add all of those numbers up together. A is 6, B is 10, C is another 10, D is 16, and E is 7.2, giving us a perimeter outside edge of 49.2 inches. Getting there. Time to talk about circles. So there's a lot of things you can do with circle math. There's a lot of applications. The main things I want you to know is that when you draw a line across the edges of a circle and you go through the center, you have created a diameter or a Pokemon ball. And if you start at the center and go to the edge or backwards the other way, you've created a radius. And the properties are 2 times the radius equals the diameter, or a radius is equal to the diameter divided by 2, or half the diameter. We have these other lines like secant that just goes through 2 points, so there's lots of different things that can be secants. Chords that connect 2 points, or tangents that touch an edge. They're not important for area calculations or perimeter calculations with circles. Our formulas. So notice we've changed the name of the perimeter to the circumference, and that just means that we're working with circles. It's its own special thing. You'll see here they've shown you a diameter is D, a radius is R, and then they have this funny symbol. Sometimes it looks like this, or I draw it like this, called pi. It's on your calculator. You can use your calculator button, or if you don't have, you're using your phone and it sucks, you can use the value 3.14 for pi. Because pi can be really long or really short, we often see answers that are a little different because of rounding at some point, and that is fine. I can figure out whether you've rounded or not, or whether you've done the right math, so don't worry about it too much. So our circumference formulas are this number pi times the diameter, or pi times 2r, which makes sense because that's a relationship between the radius and the diameter. And then area is still called area, and it is pi times the radius squared. So don't use the diameter for area. You must use the the radius, and remember your order of operations. Square it before you multiply by pi. Last set of examples. Okay, so we have what looks like a tube, but is actually an oil spill. I'll draw there we go. It's really nice oil spill, and we're going to contain it with flexible tubing. I don't know, or an oil fence of some kind. All right, so what's the area of the spill if it was a perfect circle, not what I drew, and what length of tubing must be used? So area, that's straightforward. We know that area is pi r squared. When they ask for the length of tubing, they're asking me to go around the outside of the circle. So they are asking for the circumference here. And that's fine. So let's start with the area. My diameter is 2.4, which means my radius is half of that, equals 1.2, and I must use that radius, 1.2 kilometers. So area is pi r squared. And watch that order of operations. Leave the pi till after you've squared, or do it all on a smarter calculator. And that should give you about 4.52 kilometers squared. So nice little oil spill. And we want to know what length of tubing we need, so we want to find the circumference. And you could use 2 pi r. I'm going to use pi d. Feels like less typing. So we're going to take that 3.14, or your calculator button, and you're going to multiply it by that 2.4, and all the way around the length of tubing you would need to get or bring is 7.54 kilometers. Okay, next we're doing a little crazier example. So more complicated composite figures. I want the blue shaded area, and I have to really think about what I can see here. So I'm going to try and mangle draw this picture. So I see a square. It told me it's a square, so I know this. But I also see the shape, and it says it's quarter circle removed. So at the end of the day, that means there was kind of a, oh, my land finish. Oh, missed. Okay, so there's a circle. This is the center. And this happens to also be a radius, doesn't it? So that's useful. So we're going to make our square x. That's not very handy. Our square x and our quarter circle that we're going to take out as y. And to find the area for this, we're doing a subtraction because we just want the leftover. So we want to have that square subtract that quarter circle, and that'll give us the blue part. All right, area of a square. Take that side, multiply it by itself, or square it, or just do 3.25 times 3.25, and you're going to get 10.56 centimeters squared. Trickier. The area of the circle. So well, let's start with what we know. We know the area of a circle is pi r squared. But we don't need the whole circle. We only need a quarter. So we're going to divide it by 4 because that's splitting it into 4. You could also multiply by 0.25, same thing. So we're going to do pi times, I'm going to use just this 10.56 from up there because that happens to be my r squared already. And divided by 4. And that gave me 29-ish centimeters squared. So my total area, this was my x here, I'm just going to write over that, a with an x, equals x minus y. So I'm going to take my 10.56 that I got for the square, I'm going to subtract the 8.29, which was the quarter circle, and you're going to have 2.27 centimeters squared, which is this blue part. That's 2.27 centimeters squared. 3 more to go. Another composite figure. And this one's testing our smarts too. What do I see? I kind of see, so I'm going to split it. Looks like a silo, 2D silo. bullet. We have a rectangle and we have a half circle. So I'm going to call the half circle X and I'm going to call the rectangle Y. And I'm going to be very careful with this half circle. So I see that the diameter of this circle is 22 because it's the same for the bottom of the rectangle, top of the rectangle. Okay, I don't need a diameter. I need a radius. The radius is 22 divided by 2 equals 11. So that's 11 there. It's also 11 here. That's the nature of a radius. That's all good. Okay, so I'm going to take my overall formula. I'm going to add the x and y because this is an addition composite. And I'm going to figure out my area for my circle. Pi r squared 3.14. I'm going to use that 11 and squared. I make sure I do that math first. I can't stress that enough. And then I finish off with, oh, I forgot something. Hold on. Did I use a whole circle? No, I didn't, eh? I used half a circle. So I want to split this circle in half. So right away in my formula, I should have built in divide by 2. I'm just going to tag it onto the end, which is kind of not very nice, but it will work. And we're going to get about 190 centimeters squared when we do that. Y. My rectangle, should have drawn it, then I would have seen it was a half circle, is 22. And I only have a measurement from the bottom of the figure all the way to the top. But we already decided that we had a radius going from the top of the circle to the top of the rectangle. So this piece is 11, which means this piece is 35 minus 11, 24, and that gives me the side of my rectangle. So never think that you don't have enough information. It's there somewhere. Just keep looking. So y is going to be length times width, 22 times 24, and that's going to give us 528 centimeters squared. Our total area for the win, let's make it red just so it really stands out, 190 from here. Ooh, and we're going to add that to the 528 from here, and we are going to end up at 718 centimeters squared. These are never too hard. You just have to take your time and look around. Area of the shaded region. So I have a circle and I cut out a triangle. I'm going to call that, for a total area, if I want to find the shaded area, I need to take the circle, subtract the triangle I cut out. Alright, the diameter is 16 meters, that means the radius is 16 divided by 2, which is 8 meters, and I'm ready for this circle. And just quickly, 3.14 times 8 squared. Remembering to do that square first, times 64. And that should give you 200.96. Let's just call that 201 meters squared. Okay, now our triangle. I see its base is 16. That's fine. What's its height? Its height happens to be a radius. It's going from the center of the circle to the surface of the circle. That's a radius, so its height is 8. Like I said, we always give you enough information. Okay, for y, we have base times height divided by 2. Equals 8 times 16 divided by 2, which equals 64 meters squared. So this time, to get our total area, we are going to do subtraction, 201, subtract the triangle we cut out, and we should get about 137, give or take, meters squared. Here's a bathroom. I'm going to tile it, and I want to know how much tile I need. I'm not going to tile the tub, but I will order tile for this area and all of this area. And I want to know how much I need in square feet. So I see that my measurements are in feet and inches, so I'm going to have to convert everything. So 12 feet and decimal feet rather, 4 divided by 12, 12.33 feet. I'm going to call this X, and I need this measurement over here, 7 feet 9 inches, 7 feet 9 divided by 12, 0.75 decimal feet. I don't need the tub measurements, but I am going to have to add the second rectangle Y in. 6 feet 1 divided by 12, 0.08 decimal feet. And don't make this 3.5. It's tempting. Divide 5 by 12 and realize that it's 3.42. So my area is going to be X plus Y. I'm going to get myself for X, length times width, 12.33. It doesn't matter which one's which. 7.75. And that should give you 95.56 feet squared. Stays in decimal form. Y, length times width for the water closet, equals 3.42 times 6.08. So yeah, whatever. The short one's first. No diff. 20.79 feet squared. And my total area of tile that I need to purchase equals 116.35 feet squared. So this is the stuff we're covering for our first class. Thank you for sticking with me if you're still here.